When we're talking about trig substitution, we have some patterns. If you have expression of the specific form, we can follow using substitution related to that expression. For example, if you see square root of a squared minus x squared, then the substitution is x equals to a times sine theta. Theta is bounded between negative pi over 2 and pi over 2. If you see something like square root of a squared plus x squared, the suggested substitution is x equals to a tangent theta, while theta is bounded between negative pi over 2 and pi over 2. Finally, if you see an expression of the form square root of x squared minus a squared, the suggested substitution is x equals to a secant theta. Theta is bounded between 0 and pi over 2, or theta is bounded between pi and 3 pi over 2. Let's go over one example together. In this question, we want to find the integral of 1 divided by x squared times square root of x squared plus 4 dx. We're going to use substitution x equals to 2 tangent theta because we see the same pattern that we discussed in previous slide. So since x is equal to 2 tangent of theta is x divided by 2. But remember the definition using Pythagorean theorem for right triangle. It means that the side on the right-hand side is going to be x. Down here, you're going to have 2. And then by Pythagorean theorem, the hypotenuse is square root of x squared plus 2 squared or x squared plus 4. So keep this in mind because eventually after doing the trig substitution, we have to substitute everything back and write it in terms of x. So since x is equal to 2 tangent theta, dx becomes 2 secant squared theta d theta. We're going to substitute everything into the integral, simplify as much as we can. Square root of x squared plus 4 becomes square root of 4 times tangent squared of theta plus 4. Well, you can factor out 4 and write it in front. So it becomes square root of 4 times secant squared of theta, which in turn is 2. Absolute value of secant theta. Theta is bounded between negative pi over 2 and pi over 2. So let us just get rid of absolute value sign. Very well. On the next step, we're going to see that how this integral becomes the integral in theta. So you have the integral of, on the numerator, you end up with 2 secant squared of theta d theta. And on the denominator, you have 4 tangent squared of theta times 2 secant theta. And if you simplify this further, you get 1/4 the integral of secant squared of theta d theta divided by tangent squared times secant. So you can simplify secant and secant squared, and you end up with just secant on the numerator, on the denominator, tangent squared. So when you're taking this integral with respect to theta, remember that we can separate this and write it as 1/4 the integral of 1 divided by cosine theta times cosine squared divided by sine squared. Remember the definition of secant. Secant is 1 over cosine theta, and tangent squared is sine squared divided by cosine squared. So you end up with 1 over cosine theta, which is your secant, and for your tangent squared, you can write it as cosine squared divided by sine squared. Now, this guy can be written as 1/4 the integral of, on the numerator, you have cosine theta. On the denominator, you have sine squared theta. Basically, you can cancel out cosine and cosine squared. You end up with 1 cosine and sine squared. Well, this is a simple substitution because you have u on the denominator. Du is cosine theta, d theta. Makes our life much more easier. So in calculating the integral of dx over x squared times square root of x squared plus 4, we saw that we can use trig substitution, and so far we saw it turns to be 1/4 the integral of cosine theta divided by sine squared theta d theta. The substitution, as we mentioned in previous slide, is u equals to sine theta. When u is equal to sine theta, du is cosine theta d theta that you already have on the numerator. Very good. So this guy can be written as 1/4 the integral of du divided by u squared that you already know how to calculate. This is equal to 1/4 -1 divided by u plus constant of integration. But what was u? U is sine theta. Just substitute this guy back here and you get 1/4 times -1 divided by sine theta, or -1/4 sine theta plus constant of integration. In terms, you can write this guy as negative cosecant theta divided by 4 plus c. We're not done yet because our original integral is in x, but you end up with theta here. So we need to go back to our right triangle and substitute everything back in the form of x. Again, remember that from tangent theta to be x divided by 2, and the right triangle, here you have your x, down here you have your 2, and the hypotenuse is square root of x squared plus 2 squared, or x squared plus 4. So since our integral became negative cosecant theta divided by 4 plus c, cosecant can be written as square root of x squared plus 4 divided by x. So cosecant is 1/sine, right? So you have your hypotenuse divided by x, the length in front of theta. Okay, so we have cosecant of theta in terms of x. Substitute everything. You get negative square root of x squared plus 4 divided by 4x plus constant of integration. So using trig substitution help us to calculate this integral, which is a little bit difficult to calculate in regular way. So this technique, this method help us to calculate the trig integral, the integral using trig substitution a little bit easier.